Okay, so let's have this topic. So graphing rational functions. So we have this given rational function. So first, we need to solve for the domain. And to find the domain of irrational function, we just need to equate this denominator to 0. So we have x plus 3 equals 0. Then to solve for x, transpose this positive 3, that becomes negative 3. So therefore, if x equals negative 3, this denominator becomes 0, and if the denominator is equal to 0, then that rational function becomes undefined. So therefore, this x equals negative 3 is not part of the domain. So the domain now of this rational function, so from negative infinity to negative 3, then union negative 3 to positive infinity. Or we can rewrite this one as x, elements of real numbers such that x is not equal to negative 3. So this is now the domain of this rational function. Then to solve for this x-intercept, so in solving for the x-intercept, we let y equals to 0, and from the given equation, this f of x the same as y, so therefore this equation becomes 0, then equals 2x minus 5 over x plus 3. Then to solve for x, so over 1, cross multiplication, so 1 times 2x minus 5, that's 2x minus 5, then equals 0 times x plus 3. This one is equal to 0. Then to solve for x, so transpose this negative 5. So we have 2x equals positive 5. Then divide both sides by 2. So x now is equal to 5 over 2. So to change this fraction in decimal, so 5 divided by 2, that's 2.5. So therefore, the coordinate now of this x-intercept, so x equals 2.5 and y equals 0. So this is now the coordinate of this x-intercept. Then to solve for the y-intercept, so for the y-intercept, we let x equals to 0. Then from this equation, so y equals 2 times 0 because x is equal to 0. Then minus 5, then over 0 plus 3. Then simplify, so y equals, this one is 0, this one is 0, so y is negative 5 over 3. So in decimal, so this negative 5 over 3, that's negative 1.67. So therefore, the coordinate for this y-intercept, so if x is 0, y is negative 1.67. So this is now the coordinate of the y-intercept. Then solve for the vertical asymptote. So in solving for this vertical asymptote, we just need to equate this denominator to 0. So we have x plus 3 equals 0. And to solve for x, transpose this positive 3. So x equals negative 3. So this one is the vertical asymptote. Then for this horizontal asymptote, so we just need to check the degree of the numerator and the denominator. So for the degree of this numerator, that's equal to 1. And the degree of this denominator also equal to 1. Since the degree of the numerator is equal to the degree of the denominator, so therefore the horizontal asymptote is the ratio of this numerical coefficient. So therefore, y is equal to 2 over 1. Then reduce, so y is equal to positive 2. So this one is the horizontal asymptote. So since we have now this coordinate of the x-intercept, coordinate of the y-intercept, the vertical asymptote, and the horizontal asymptote, so we can place now this one in a graph. So for this vertical asymptote, that x equals negative 3, so this one is x, this one is y, so x is negative 3, so this one is the vertical asymptote. Then for this horizontal asymptote, so y equals positive 2, so this one is y positive 2, so this one is the horizontal asymptote. Then we need to plot this coordinate of the x-intercept. So x equals 2.5 and y is 0. So this point is the coordinate of the x-intercept. And for this y-intercept, so x is 0 and y is negative 1.67. So this point is the coordinate of the y-intercept. Then to find the graph of this rational function, we're going to use a table values. So this one is x and this one is y. So for x, from the vertical asymptotes, we just need to take a numbers from the left and the right of these vertical asymptotes. So I'm going to use these numbers, so negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So x is negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, and negative 3. Then for the right, we have this negative 2, negative 1, 0, 1, 2, and 3. So we have negative 2, negative 1, 0, 1, 2, and 3. So you can extend the numbers to find the graph of this rational function. So to solve for y from this equation, so just substitute the value of x. So let's start with x equals negative 9. So from this equation, so if x equals negative 9, so using calculator, so again, if x equals negative 9, so 2 times negative 9 equals then minus 5 equals then divide. This one is negative 9 plus 3, that's negative 6. So therefore, divide by negative 6, that's positive 3.83. So this one is positive 3.83. Then if x equals negative 8, so we have 2 times negative 8 equals then minus 5 equals then divide. So negative 8 plus 3, that's negative 5. So divide by negative 5, that's positive 4.2. So this one is 4.2. Then if x equals negative 7, so we have 2 times negative 7 equals minus 5 equals then divide. So negative 7 plus 3, that's negative 4. So divide by negative 4, that's 4.75. So this one is 4.75. Then for x equals negative 6, so we have 2 times negative 6, then equals minus 5 equals then divide. So negative 6 plus 3, that's negative 3. So divide by negative 3, that's 5.67. So this one is 5.67. Then for x equals negative 5, so 2 times negative 5 equals then minus 5 equals then divide. So negative 5 plus 3, that's negative 2. So therefore divide by negative 2. So that's 7.5. So this one is 7.5. Then for x equals negative 4, so we have 2 times negative 4 equals then minus 5 equals then divide. So negative 4 plus 3, that's negative 1. So therefore divide by negative 1. That's positive 13. So this one is 13. Then if x equals negative 3, so again, this becomes 0. So if the denominator is 0, this one is error. Then for x equals negative 2, so we have 2 times negative 2, then equals, then minus 5, equals, then divide. So negative 2 plus 3, that's positive 1. So divide by 1. This one is negative 9. Then for x equals negative 1, so 2 times negative 1 equals then minus 5 equals then divide. So we have negative 1 plus 3, that's positive 2. So divide by positive 2, that's negative 3.5. So this one is negative 3.5. Then for x equals 0, so if x is 0, so 2 times 0 equals minus 5 equals then divide. This one is positive 3. That's negative 1.67. So this one is negative 1.67. Then if x equals positive 1, so 2 times 1 equals minus 5 equals then divide. So x is 1, so 1 plus 3, that's 4. So that's negative 0.75. So this one is 0.75. Then if x is 2, so we have 2 times 2 equals then minus 5 equals then divide. So 2 plus 3, that's 5. That's negative 0.2. So we have negative 0.2. Then the last one, if x equals positive 3, so that's 2 times 3, then equals minus 5 equals, then divide. So 3 plus 3, that's 6. So divide by 6, that's 0.17. So this one is positive 0.17. So we have now all the values. So we're going to plot now these coordinates in the graph. So start with x equals negative 9 and y is positive 3.83. So if x is negative 9, so this one is negative 9 and y is positive 3.83. So 1, 2, 3. So maybe this one is 0.83. So this is now the point of this negative 9 and 3.83. Then for x equals negative 8, so this one is negative 8. Then y is 4.2. So 1, 2, 3, 4. Maybe this one is 0.2. So this is now the graph of this negative 8 and 4.2. Then for this negative 7, so negative 7 and y is 4.75. So maybe this one is 4.75. So this is now the graph of negative 7 and 4.75. Then for negative 6, and y is 5.67. So 1, 2, 3, 4, 5. So maybe this one is 0.67. So 6.67. So this is the point. Then for this negative 5, then 7.5. So 1, 2, 3, 4, 5, 6, 7. And this negative 5, this is the point. Then for this negative 4, so negative 4. And y is 13. This one is 13. So this is the point. So we can connect now the graph. So this is now the graph of this rational function. Then the other one, so on the right side, so if x equals negative 2, so negative 2, then y equals negative 9. So this one is negative 9, this one is negative 2. So this one is the point. Then if x equals negative 1, so that's negative 3.5. So this one is negative 3, negative 3.5. So maybe this is the point. Then if x is 0, so this is the point. Then if 1, that's 0.75. So this one is the point. Then if 2, that's negative 0.2. So if 2, so this point. Then if 3, that's positive 0.17. So this is the point. Then we can connect now the points. So this is now the graph of the given rational function.